Welcome to the show. Today, we are undertaking a really thorough examination of one of the world's most recognized and, just enduring brands.
It's a truly fascinating subject.
We're talking about the massive, precision-engineered empire built on interlocking plastic bricks, the Lego Group.
It is fascinating because, at its heart, the entire corporate infrastructure, which is now the world's largest toy manufacturer by sales, it all revolves around a single, highly standardized product.
Right.
So our mission today is to really extract the essential insights from the company's history, understand the astonishing technical rigor behind the manufacturing, and, well, analyze its evolution into this global force in media, robotics, and even adult entertainment.
To give you a complete picture without getting lost in all the details.
Exactly.
And when we talk about the volume here, the numbers are just staggering. The core product is, of course, that interlocking brick made from ABS plastic.
That's acrylonitrile butadiene styrene.
Right. And the sheer scale of production, it just sort of defies easy comprehension. To give you an anchor point, by July 2015, the company had produced an estimated 600 billion individual Lego parts.
600 billion.
That's the scale we're dealing with today. And it all started in a small carpentry workshop in Denmark.
And to really appreciate that massive figure, we absolutely have to start at the beginning. It's rooted in a philosophy that was established nearly a century ago.
So the Lego Group, it began in 1932 in Billund, Denmark.
That's right. It was the carpentry workshop of Ole Kirk Christensen, who lived from 1891 to 1958. And initially, he was just focused on crafting wooden toys, a classic traditional product.
And what's so compelling is that this early foundation wasn't just about making things to sell. It was immediately about setting an almost impossibly high standard for quality.
That became their defining trait.
Exactly. The company's name itself, that came a couple years later in 1934. Christensen needed a name for his growing enterprise.
And he coined Lego.
He did, from the Danish phrase "leg godt," which translates pretty simply to play well.
It does. It just captures that spirit of encouraging, rich, imaginative play.
But the real insight for me comes from the motto, the internal rule Christensen instituted in 1936.
Yes.
It's often quoted as, only the best is good enough. But when you look at the original Danish, "Det bedste er godt" for God, the literal translation is even more uncompromising.
It is. It means the best isn't excessively good.
Which is such a powerful way to put it.
And that phrase, that is the DNA of the modern company. Christensen used this motto to justify using higher quality materials even when cheaper alternatives were, available.
He famously insisted on it.
He did, even when cost cutting might have been more advantageous in the short term. And this commitment prioritizing quality and durability above all else is what allows the modern Lego Group to maintain its 10 micrometer precision today. It all starts with that 1936 decree.
So that initial high standard was put to a pretty significant test in the late 1940s when the company decided to transition from wood, a natural established material, to plastic.
This was a pivotal moment, and a rather risky one. Lego expanded into manufacturing plastic toys in 1947. Then, in 1949, they produced the automatic binding bricks.
These were the early versions of the interlocking product we'd recognize.
They were. But it's so important to realize this shift was happening against a huge wave of skepticism.
It sounds like plastic wasn't really taken seriously as a material for durable toys yet.
Not at all. We see evidence in Danish trade magazines of the time, something like Legette's Tidend or Toy Times, where articles were published in the early 1950s stating quite confidently that plastic could never replace traditional, robust wooden toys.
The perception was that it was flimsy.
Yeah.
Cheap.
Exactly.
Yet, despite that prevailing opinion, the transition inside the company was incredibly fast.
It was. By 1951, so just 4 years after introducing plastics, they accounted for half of the company's total output. The market was clearly ready for something new, even if the traditionalists weren't.
We should also probably acknowledge the origin of the interlocking concept itself. It wasn't an entirely original invention.
That's a key point. The inspiration came from the UK, correct?
That's right. The concept was heavily influenced by the Kiddicraft self-locking bricks.
Invented by Hilary Page, who patented the design in the UK way back in 1940, Lego actually received a sample of these Kiddicraft bricks from the distributor of an injection molding machine they had just acquired. So they adapted, and really they significantly refined an existing concept, elevating it to an engineering art form.
So the early bricks existed, but they still weren't quite the universal system we know today. What was the catalyst for that final defining innovation?
Well, that happened around 1954. Ole Kurt Christensen's son, Gottfried, became the junior managing director.
And this is where the shift happens, from just having interlocking toys to conceiving of a whole toy system.
Precisely. Gottfried realized the bricks couldn't just be individual sets, they had to be infinitely combinable.
What were the technical issues with those early bricks that stopped them from being a true system?
Well, the initial materials, like cellulose acetate, they just weren't rigid enough. And the design itself, it suffered from limited locking ability.
So if you stack them too high or tried to build outwards,
The connections were weak, it really reduced the versatility and the scope of play. Gottfried's crucial insight came from a conversation with an overseas buyer. He recognized that the real power was in creating a single, universal platform where every piece was mathematically and physically compatible with every other piece.
this wasn't just a creative insight then. It sounds like a massive economic insight.
Oh, absolutely. Creating a system encouraged continuous purchasing and expansion rather than just one-off toy purchases.
And that conceptual leap led directly to the invention of the modern brick, which still defines the product line today.
It did. The definitive modern brick design was developed in 1958. It solved those earlier technical shortcomings by incorporating the inner tubes that provide that necessary clutch power and structural stability.
And the patent was filed.
The patent application for this specific design was filed in Denmark on January 28, 1958, marking the birth of the enduring system.
And the material evolved pretty rapidly to meet that new engineering standard.
It did. The original cellulose acetate was quickly replaced 5 years later by ABS plastic. ABS provided the durability, the rigidity, and the ability to maintain those extremely tight tolerances needed for consistent clutch power. This material remains the standard today, a testament to its effectiveness.
So that journey from a wooden toy workshop in 1932 to the patented ABS plastic system of 1958, that really encapsulates their philosophy.
It does. The relentless pursuit of quality necessary to fulfill the promise of play well.
Speaking of that relentless pursuit of quality, let's move from the history to the absolute hard science that underpins Lego's success. Because the fundamental genius of the Lego brick isn't its shape, it's the consistency. It's a system that demands universal compatibility across time.
That is the defining engineering principle. The fact that a brick molded in 1958 will seamlessly lock with a piece molded just this year is an enormous constraint to maintain. It means their manufacturing processes cannot drift, even marginally, over 7 decades.
And the mathematical implications of this system are so often overlooked because the pieces look so simple.
It's deceivingly simple. Consider that famous statistic. If you take 6 standard 2x4 stud bricks, they can be combined in an astounding 915,103,765 different ways.
Almost a billion combinations.
From just 6 little blocks. This combinatorial potential is the definition of creative freedom, but it only works if those blocks are produced with near-perfect fidelity.
And that perfect fidelity requires just astonishingly tight tolerances.
Yes. The manufacturing machines, the injection molds, they have to operate with extreme precision. The tolerances permitted for the bricks themselves are as small as 10 micrometers. For the molds, it's about 20 micrometers.
To give some context, the average human hair is what, about 75 micrometers thick?
Exactly. So we're talking about precision measured at less than 1/7 the width of a human hair. If the bricks deviate even slightly outside this range, the clutch power, how firmly they lock and how easily they detach, is compromised.
And the entire system fails.
The whole system fails.
So how does the manufacturing process actually achieve this level of precision at such an incredibly high volume?
It's an intense, high-tech operation. It involves specialized injection molding. They start with ABS plastic granules, which are heated until they reach this dough-like consistency, around 232 degrees Celsius or 450 Fahrenheit.
And this molten plastic is then forcefully injected into those highly precise steel molds.
And the pressure required for that injection must be just immense to capture every tiny detail.
It is. The plastic is injected under tremendous pressure, using forces up to 150 tons. The cooling time is incredibly fast, around 15 seconds, and then the perfectly formed brick is ejected. The molds themselves are engineering marvels.
They often cost tens of thousands of dollars.
And they're designed to withstand this repetitive, high-pressure, high-temperature cycle millions of times while maintaining that 20 micrometer precision.
And the success of this process is best illustrated by the quality control figures, which, well, they really bring the founder's motto into the 21st century.
This is maybe the most defining statistic of the company's technical identity.
I would agree. According to the Lego Group, out of every million bricks they produce, only about 18 fail to meet their stringent quality standard.
18.
per million.
18 failures per million. That microscopic failure rate demonstrates an obsession with consistency that few mass manufacturers can match. It's what assures you that when you open a brand new set, every single piece will function exactly as promised.
And this is all happening at a blistering pace across their global network.
The scale is just colossal. Annually, they average 36 billion bricks. If you break that down, that means approximately 1,140 elements are produced every single second.
Every second. Across all their operational factories. To manage that flow, that volume, and still maintain that 18 per million failure rate is an extraordinary feat of logistics and engineering.
And to give listeners an unexpected context for this manufacturing scale, there's that fascinating and slightly humorous claim about their tire production.
Yes, that's a wonderful illustration of scale. In 2006, based purely on the volume of small rubber tires manufactured for the wheels in their vehicle sets, it was estimated that the Lego Group could legitimately be considered the world's #1 tire manufacturer.
Producing how many?
Around 306 million small rubber tires a year. Now, these aren't full-size car tires, of course, but that number just underlines how massive and pervasive their component production is.
Beyond production, the engineers have put these pieces through extreme physical stress tests to understand their actual structural limits.
And they are far tougher than they appear. There was a famous experiment conducted by the BBC and the Open University. They tested the load capacity of a single 2x2 brick.
And what do they find?
They found that this small block can withstand an average maximum force of 4,240 newtons. So the calculations showed that to crush the bottom brick in a stack, you would need to stack 375,000 standard 2x2 bricks directly on top of one another.
That is an impossible height in the real world.
It is. That stack would reach a height of 3,591 meters. That's almost 12,000 feet. This level of structural integrity, achieved with only ABS plastic and a specific internal geometry, is just incredible.
And private tests have shown that the bricks can withstand thousands of assembly and disassembly cycles before showing significant wear.
Thousands. These bricks are effectively designed to last forever.
And that structural integrity, that longevity, that brings us to their global footprint, which is rapidly evolving as the company grapples with the long-term implications of making such a durable, long-lasting plastic.
Well, the current manufacturing network includes molding operations in Denmark, Hungary, Mexico, and China. Decoration and packaging are also handled in the Czech Republic, but the future is focused very heavily on sustainability and expansion.
We see that massive commitment in their new factory projects, particularly in North America.
Absolutely. They're investing over $1 billion into a new carbon-neutral factory near Richmond, Virginia. It's scheduled for completion in 2025.
And the ambition here is total self-sufficiency.
It is. The factory is designed to be powered entirely by rooftop and ground solar panels, generating 35 to 40 megawatts on site. They also opened their 6th factory worldwide in Vietnam in 2025, which they've described as their most environmentally sustainable factory to date.
And these massive investments are directly related to their goal to move away from ABS plastic entirely. They've set a very ambitious deadline for that.
They have a self-imposed 2030 deadline to find eco-friendly alternatives for the majority of their products. They've made some inroads, Since 2018, all their botanical elements, leaves, bushes, trees have been made from bio-derived polyethylene.
They also committed to eliminating single-use plastic bags for packaging.
Right, transitioning to recyclable paper bags, which is a huge logistical change.
But the real challenge, it lies in finding a suitable replacement for ABS, the core material. And their attempts really highlight just how complex true environmental sustainability is in advanced manufacturing.
It's immensely difficult, and the journey is filled with reversals. They had been working on producing bricks using recycled polyethylene terephthalate, or RPE.
Which is derived from recycled plastic bottles.
Right, but they reversed this major decision in 2023.
So why did they abandon RPE if it was made from recycled material?
This is where the analysis has to go beyond those surface-level green claims. They found that, when calculating the entire life cycle analysis, switching to RPE did not actually reduce the carbon dioxide emissions of the finished product compared to using virgin ABS.
So the conversion process, the additives, the energy required to make it meet their standards.
All of it meant the overall carbon footprint wasn't significantly better, and it's a powerful lesson in material science. Sustainability requires more than just using recycled feedstock. It demands maintaining quality while genuinely reducing emissions across the entire chain.
It really underscores the difficulty of upholding that only the best is good enough standard, while also meeting aggressive environmental goals.
Precisely. They cannot compromise the structural integrity or the core system compatibility. On a positive note, though, their current factory operations are highly efficient, recycling 99% of all plastic waste generated during the actual manufacturing process. The goal now is to solve that input material challenge by 2030.
The endurance of the brick is proven by the engineering, but the endurance of the company is proven by its ability to evolve the system without breaking those compatibility rules. Two strategic additions really broadened the market scope.
The first, introduced in 1969, was Duplo. This was a critical expansion aimed at a much younger demographic.
The blocks are scaled up.
Exactly. Duplo blocks are precisely scaled to be twice the width, twice the height, and twice the depth of standard bricks. This made them safer, easier to handle for toddlers, and critically, still perfectly compatible with the standard Lego system when children grew older.
And the second innovation, introduced a decade later, truly personalized the building experience and allowed for robust storytelling.
That would be the minifigure, introduced in 1978. Before the minifigures, sets focused almost entirely on structures and vehicles.
But these little yellow, smiling, articulated figures, they quickly became a staple.
They transformed structures into scenes and vehicles into vehicles with drivers. It added a narrative layer that was previously absent or, very limited.
Over the decades, the product line diversified into complex and distinct product themes.
We see the enduring power of the classic themes. Lego City, introduced in 1973, provides the systematic depiction of modern life, police, fire, construction.
And then there's Lego Technic.
Right, introduced in 1977. That completely changed the complexity level. It moved beyond simple studs and sockets to use specialized components, axles, gears, pins, to emulate complex machinery and mechanical function.
But the massive inflection point for the company's revenue and cultural visibility came through licensed themes.
That shift began in earnest with Star Wars, and then it expanded to encompass these enormous global franchises like Harry Potter, Marvel, and Minecraft. Licensing properties connects the Lego brand directly to contemporary pop culture.
And it guarantees high sales, especially around major film releases.
Right. But we also see evidence that the company is trying to manage the balance between this highly profitable licensing model and maintaining control over its own creative destiny.
That tension is real.
It is. In 2015, the Lego Group publicly stated a strategic desire to rely more heavily on their own original intellectual property and classic themes and less on licensed properties.
So while licensing is lucrative, it introduces volatility and requires paying royalties.
Exactly. By emphasizing themes like Lego City or Ninjago, which is their own IP, or Technic, they reinforce their brand autonomy and keep all the creative control and long-term profit.
And perhaps the most fascinating market shift in recent years has been the overt recognition and capitalization on the adult consumer.
The term AOL's adult fans of Lego has moved from a niche internet subculture to a massive corporate revenue driver. In 2020, Lego made this official. They introduced sets specifically targeted at and labeled for adults aged 18 and older.
And these are often their most challenging and expensive sets.
Oh, yes. Featuring detailed, iconic replicas like the Concorde supersonic jet or the incredibly intricate Rivendell set from The Lord of the Rings.
And the timing of this strategic push was remarkably fortunate, coinciding with a massive shift in global behavior.
It was almost perfectly timed. The launch of these sophisticated adult sets coincided favorably with the COVID-19 pandemic and the widespread lockdown periods across the globe.
So millions of adults, suddenly forced to seek engaging, tangible hobbies at home,
gravitated toward Lego, viewing it as a therapeutic and absorbing activity, and this significantly boosted sales to the adult market.
And the data shows this isn't just a pandemic-era fluke, it's a permanent shift in consumer strategy.
Absolutely. By 2024, the results were clear. Nearly 15% of all sets released in the United States were specifically aimed at adult builders. The popularity was fueled further by media exposure, not just the Lego movie, but also the reality television series, Lego Masters,
Which celebrated adult construction skill.
Exactly. This is a demographic with high disposable income, and the company has successfully transitioned from a children's toy purveyor to a global entertainment and hobby brand.
And this intense focus on the adult market has also led to an escalating race for the title of largest commercially produced set.
It's a fun piece of corporate bragging rights, and the record seems to change hands every few years. If we trace the title, it was held by the Ultimate Collector's Millennium Falcon in 2007, with 5,195 pieces.
That was then eclipsed by the Taj Mahal set,
which had 5,922 pieces. But then the Falcon returned in an expanded form. A redesigned Millennium Falcon reclaimed the title in 2017 with 7,541 pieces, a monumental set at the time.
However, the subsequent years have seen the piece count just explode.
They really have. The current record holder is the LEGO Art World Map, which clocks in at an astounding 11,695 pieces.
And just behind it are other giants.
The LEGO Titanic with 9,090 pieces and the LEGO Architect Colosseum with 9,036 pieces. The complexity and piece count just keep rising.
And the size isn't only measured by the number of components. Physical height is also a measure of their design ambition.
The tallest commercial set available today is the 2022 Eiffel Tower. It's constructed from 10,001 parts and reaches a remarkable height of 149 centimeters.
That's almost 5 feet tall.
It is. And beyond commercial releases, the sheer scale of the community's imagination pushes these limits even further. We've seen evidence of truly monumental, record-breaking projects constructed by fans and company builders.
Like the 34-meter tower?
A tower that reached 34 meters, or 112 feet tall, built in Hungary, and an incredibly ambitious 4-kilometer or 2.5-mile-long railway constructed entirely out of Lego elements. These massive builds demonstrate that the standardized, scalable system established in 1958 holds up not just under microscopic scrutiny, but also under architectural scale.
The universal system of the brick also allowed it to integrate seamlessly into a much higher-tech domain, robotics. The launch of the Mindstorms line took Lego out of the traditional toy chest and placed it squarely in the computer science curriculum.
Mindstorms, which ran from 1999 until its eventual retirement in 2022, was a genuinely transformative product. Its origins trace back to the MIT Media Lab, where the initial programmable brick concept was developed.
And the name itself is significant.
It is. It was taken from a paper by computer scientist Seymour Papert, who is a champion of constructionism in education. The idea that learning is most effective when you're constructing a tangible public artifact. The LEGO Group actually partially funded Papert's work.
So the product was designed from the ground up to be an educational tool, encouraging creative construction with digital technology.
Precisely. The system centered around a programmable brick, the final version being the EV3 brick, which acted as the brain. The kits included various sensors, touch sensors, light sensors, sound sensors, and ultrasonic waves.
Allowing the robots to interact dynamically with their environment.
Right. And the official software was graphical drag and drop, making programming accessible to novices. Programs were uploaded to the brick, initially via infrared, but later versions used Bluetooth or a USB cable.
And crucially, the open nature of the robotics community meant fans developed unofficial programming languages.
They did. Things like not quite C and not exactly C, demonstrating how the platform fostered this sophisticated ecosystem of digital builders.
This functionality quickly moved Mindstorms into the realm of organized competition, becoming a cornerstone of youth engineering events globally.
Oh, absolutely. Mindstorms became integral to global robotics competitions. First LEGO League, for example, is structured around 3 age groups: Discover, Explore, and the intense challenge level for students aged 9 to 16. These events require students to design, build, and program autonomous LEGO-based robots.
The kits were also heavily used in international events like RoboCup Jr.
Right, which often pushed the programming complexity to its absolute limit.
While those competitions are impressive, perhaps the most profoundly impactful application of the Mindstorms technology emerged not in a classroom or lab, but in a field dedicated to improving children's lives.
I agree. This is where the systematic nature of the product intersects with profound human potential. You're referring to the ICO Creative Prosthetic System.
Designed by Carlos Arturo Torres, specifically for child amputees. Explain how the LEGO system was integrated into the prosthetic.
Well, the ICO system was modular. It featured a base unit that connected to the child's limb stump. This base unit contained myoelectric sensors, which are critical.
Okay, wait, what are myoelectric sensors exactly?
Right, so they're highly sensitive sensors that read the tiny electrical signals generated by muscle movement in the remaining limb stump. When a child consciously flexes a specific muscle, the sensor detects that electrical impulse and sends a signal to the prosthetics processing unit.
Which allows the child to control the motion of the attached hand, or in this case, the attachment base.
Absolutely. The end of the prosthetic was designed to accept standard LEGO connections, and the processing unit was fully compatible with LEGO Mindstorms. This allowed the wearer, the child, to completely customize their limb using standard LEGO bricks.
So it could build fun, imaginative, and programmable attachments.
Things like mechanical diggers or laser-firing spaceships. It turned a functional medical device into a tool for creative play. The collaboration between the designer, the LEGO Future Lab, and a Colombian Foundation for Rehabilitation seems to have focused on empowerment.
That seems to be the key word, empowerment.
It is. By leveraging the universality of the LEGO system, they transformed what could be a source of self-consciousness into an evolving, customizable, and unique feature. The child could constantly modify their limb to match their imagination. It's just a powerful example of how creative construction can be a tool for rehabilitation and confidence building.
Moving from physical and biological applications to the purely digital realm, the company has also been focused on building out its proprietary online environments.
They've recognized the need to provide safe digital spaces for their core audience. The most notable example is LEGO Life, a social media app designed specifically for children under the age of 13.
And given the concerns around children's online safety, how do they manage that environment?
Safety is paramount and heavily built into the architecture. It's a heavily moderated platform. All user-generated content creations, photos, videos are filtered before being posted. Communication is also restricted to pre-approved phrases or emojis.
So they're preventing the exchange of personal or inappropriate information.
That's the goal. The platform maintains a strict policy on protecting personal information, ensuring it remains compliant with global child protection laws.
They also attempted to bridge the digital design world with physical models using their software platform.
That was LEGO Digital Designer, official software that allowed users to create and manipulate virtual LEGO models. Initially, the most exciting feature was the ability for customers to order physical models of their custom digital designs to be shipped to them.
But that service was discontinued in 2012.
It was. Now, the company recommends that digital designers switch their work to Bricklink Studio, another specialized design software the company now endorses.
Finally, let's discuss a unique application of the brick that has nothing to do with children or toys, but everything to do with corporate strategy and creative thinking.
This is LEGO Serious Play, a business consultancy method that the LEGO Group began promoting around the year 2000. It uses the bricks as a tactile, three-dimensional tool for communication and problem-solving in corporate settings.
So how does that method actually work?
Teams or individuals are given a challenge or a strategic question like, what is our company identity? Or what does a successful merger look like? They then use LEGO bricks to physically build metaphors representing their organizational identities or experiences.
And the physical act of building and discussing the model fosters creative thinking.
Exactly. It leads to richer, more candid discussions than a traditional meeting. It's a very serious form of play aimed at unlocking dormant creativity.
The LEGO Group's identity is now split across manufacturing, digital services, and massive global entertainment. The theme park operations alone represent a vast enterprise.
They certainly do. There are currently 10 Legoland amusement parks operating worldwide. These include the original park in Billund, Denmark, as well as major locations in Windsor, California, and new parks opening in Shanghai and New York.
But it's crucial context that the LEGO Group doesn't fully operate these parks.
That's right. They sold 70% control to the Blackstone Group and Merlin Entertainments back in 2005, though they maintain a minority stake and significant brand involvement.
And beyond the theme parks, their retail footprint is extensive and growing rapidly.
As of March 2024, the company operates over 1,031 branded retail shops globally. And while the global rollout is a relatively recent phenomenon, it's interesting that the very first dedicated LEGO store opened much earlier in Sydney, Australia in 1984.
Today, the flagship store is the massive operation in Leicester Square, London.
Right. And culturally, the brand became a media powerhouse, changing how the world perceived the plastic brick forever.
The transformation was really cemented by the LEGO movie franchise, which launched in 2014.
A massive commercial and critical success. It proved the bricks could support complex narratives and humor, spawning spin-offs like the LEGO Batman movie and the LEGO Ninjago movie.
And the cultural relevance is so high that they are now using the medium to tell real-world biographical stories.
Yes, the upcoming 2024 biographical film, Piece by Piece, will focus on the life of singer Pharrell Williams. This move highlights the brand's position as a legitimate, recognized storytelling medium. It's transcending the idea of merely being a toy commercial.
The brand's place in cultural history is secure. It's been acknowledged by institutions.
The cultural impact is undeniable. The bricks were inducted into the National Toy Hall of Fame in 1998. It's also important to note the company's intense protection of its trademark. They insist that Lego should always be used as an adjective.
As in Lego bricks or Lego set.
Right, rather than a mass noun like some Lego or a plural like Legos, although that latter usage is extremely common, especially in informal American English.
Let's turn now to a cultural phenomenon that illustrates the durability of the product in a completely accidental way. The Cornwall spill.
This incident provides a dramatic, real-world stress test of the ABS plastic. In 1997, 5 million Lego pieces destined for the U.S. market were swept into the Atlantic Ocean off the coast of Cornwall, England.
When a rogue wave hit the cargo ship Tokyo Express.
Exactly. And those pieces are still washing up today, decades later.
They are. These lost pieces, including specific nautical-themed items like flippers, plastic octopuses, and a famous Lego shark, they've been washing up on Cornish beaches for over 25 years.
A Lego shark was recently found in 2024.
This unfortunate event serves as a bizarre testament to the near immortality of the ABS plastic components.
It really does.
And on a lighter note, the other persistent cultural touchpoint is the exaggerated pain of stepping on one.
That's true. It's a common running joke, humorously exaggerated in popular culture. The brick, because of its rigidity, its precise 90-degree corners, and its low profile, is frequently compared to a caltrop,
A medieval weapon designed to inflict damage on feet.
which highlights the unique geometry of the piece in a playful way.
Now we have to delve into the persistent, complex, and often adversarial legal battles over intellectual property, which have shaped the market for building blocks globally. The expiration of a key patent was the turning point.
The most crucial date in Lego's legal history is 1978. That is when the last significant patent protecting the fundamental 8-peg interlocking brick design expired.
So once that happened, competitors were legally free to produce blocks with similar dimensions.
Blocks that could connect to Lego bricks. This immediately created the category known as clones.
And Lego's legal response has been aggressive, but often met with complex judgments regarding what can and cannot be trademarked in a functional object.
They've had a very mixed record in the courts. They successfully won a copyright infringement case against the Coco Toy Company in Beijing in 2002. However, they faced significant defeats regarding the protectability of the brick's shape itself.
They lost trademark protection for the shape of the brick in Germany.
Against a competitor called Best Lot Construction Toys. And perhaps the most impactful loss was in Canada against the makers of Mega Bloks.
That 2005 case went all the way to the Supreme Court of Canada, and Lego lost.
They did. The argument was that the shape of the brick was not about branding. It was about the technical function of the toy. It was necessary for the brick to work within the system.
And this principle, that functional elements cannot be trademarked, was solidified across Europe years later.
Correct. The final nail in the coffin for trademark protection of the shape came in 2010. The European Court of Justice ruled that the specific 8-peg design of the brick merely performs a technical function.
Since trademarks are meant to distinguish the source of a product, not its utilitarian function.
The design could not be trademarked. This forced the Lego Group to shift its focus entirely from protecting the basic shape to relying on branding, minifigure design, set instructions, and, critically, their unwavering quality standard.
This ongoing battle, often referred to as the Clone Wars, resurfaced with significant community opposition in the early 2020s.
It did. In 2020 and 2021, the company began sending cease and desist letters to small toy retailers and even popular YouTubers in Germany who were promoting clone brands.
And in one notable incident, a shipment of bricks from a clone producer called Cube Man was blocked from entering Germany.
Right, due to intellectual property concerns raised by Lego.
And the community's reaction to this aggressive enforcement against smaller entities was surprisingly forceful.
It was a fascinating display of consumer solidarity. The small retailer who was targeted initiated a public appeal. They asked for donations not just to fight the legal battles, but to import containers of Lego clones from China to Germany and donate them to children's homes.
That is a remarkable use of a negative situation to create a positive outcome.
It really struck a deep chord with the community. It demonstrated a feeling that construction play should be universally accessible and affordable. The appeal was incredibly successful, raising over $350,000 souls within a few weeks.
It just highlights the tension between a corporation's need to protect its multi-billion-dollar brand identity and the community's desire for open, affordable access to the fundamental concept of interlocking play.
What this entire examination reveals is a portrait of a company defined by that 1936 motto, "Only the best is good enough." We've seen a historical simplicity meet complex engineering constraints, resulting in a microscopic failure rate of 18 per million.
And that dedication to precision underpins the entire global expansion.
From film and media to robotics and the adult market. Even in the face of legal defeats regarding the core product shape, the company relies on its manufacturing fidelity and the power of its systematic, expandable play to maintain its dominance.
Indeed. We have covered a product that supports immense weight, lasts for potentially thousands of assembly cycles, and has been produced in the hundreds of billions, 400 billion, by 2008 alone.
An incredible number.
So given that level of extreme durability and the massive number of ABS plastic pieces already in circulation and designed to last centuries, what is the long-term environmental and cultural legacy of an object that is fundamentally engineered to last forever? That is a profound question regarding the future of material science and play. Thanks for listening.